So, good morning everyone. I'm Jarin Cobol and I'm going to report Design Flood Discharge Part 2. So, drainage area and shape-based formulation. Under pa rin na siya sa first reporter na flood design discharge. And the following formulation take into consideration additional variables such as the shape factor. For instance, dredge or Burge formulation is based on Indian record states that QP equals 19.6 times A over L to the power of 2/3, where L is the length of the drainage basin in kilometer. On the other hand, if W is the average width of the basin in kilometer, then substitution of A equals WL into the previous expression leads to QP equals 19.6 WL to the power of 1/3. Then rainfall and drainage area based formulation. The original developments of such formulation are from northern USA, Ohio to Connecticut as QP equals CP times PW to the 5 over 4, where P is the probable 100-year maximum one-day rainfall in centimeter and CP is the flood constant equal to 1.5 for humid areas and 0.2 for desert areas. The formula requires in its application fairly uniform with no storage effect. The application validity of this formulation is confined to area from 1,600 to 16,000 kilometers squared. If the area is wider at the lower end, the formula gives us two small result and it's wider and its super ends. The result obtained are too large. A correction of 10 to 13% may be required for width variation. Then total runoff and drainage area based formulation. The most widely known alternative to this group of formulation is the Boston Society of Civil Engineers formula, which is suggested by the Flood Committee of Boston Society of Civil Engineers per square kilometer, that is based on the New England flood November 1927, and QP equals 0.0056 D over T, where QP is the peak flow and D is the flood runoff depth in centimeter and T is the total flood period in hours or base of the flood hydrograph. Then rainfall intensity and drainage area based formulation. This is referred to as the rational formulation, which is the oldest and best known formula for determining peak flow from a given drainage area. The peak discharge QP formulation is given as follows: QP equals 0.28 CIA, where QP is obtained in cubic meter per second on the base that the rainfall intensity, and I is the millimeter per hour and drainage area is in kilometer squared. General assumption in this rational formula are that the predicted peak discharge QP has the same probability of occurrence return period as the used rainfall intensity I. Therefore, coefficient C is constant during the storm rainfall and precision time is equal to the time of rise. Then on the other hand, in the modified version of rational formula, a storage coefficient CS is included to account for a recession time larger than the time the hydrograph take rise, and QP equals 0.28 CS times CIA. In a drainage basin, the peak flood discharge is reached when all parts of watershed are contributing to the outflow at the time of concentration in minutes. which is given by Kirpich 1940 on the basis of main channel length in meter and slope s. So TC equals 0.019 L to the power of 0.77 times S to the power of negative 0.385. Then envelope curves. If in a region same climatological characteristic, the flood record data is scarcely available, then the envelope curve technique is adapted to develop a relationship between the peak flood discharge QP and the drainage area A. Envelope curves are very useful in getting quick estimation of peak flood design discharge values if equations are fitted to the envelope curve, then it provides the empirical flood formulae of the type Q equals FA. So, natay flood discharge envelope curves. Then, ano siya? Engineering water structure design. There are different methodologies which each water-related problem has its specification, formulation, and calculation method. And debris flow. During flood, these are liquefied, fast-flowing landslide mixtures of unconsolidated water and debris. They are in the form of very dense fluids full of sands, gravel, cobbles, boulders, and fine grains. It is necessary to construct small dams, retaining walls, artificial sealing, depression, wire network, and similar hindrances against their flow in order to maintain usable structure safety. Then debris flow calculation. And QP equals 0.0375 V to the power of 0.7143, or reverse of this expression as the debris flow volume subjected as V equals 26.57. Then rockfalls are only from natural slopy hills slides along the road alignment, but also from insufficiently protected rock cuts. Stabilization force on rock masses can be disturbed by some climatic or biological event under the gravitational effect over road cut or natural hill slope. Then canals. Artificial engineering water structures that collect and transport surface flow to the sea or to any desirable outlet point. So, groundwater velocity calculation. In the groundwater studies, velocity calculation can be achieved according to Darcy law, where the necessary parameters are hydraulic gradient, slope, and hydraulic conductivity K. V equals Ki. Hydraulic gradient can be found from groundwater level measurements or groundwater table maps. So, natay values ni K like sa yang rock type, grain size, and hydraulic conductivity. Then gully and sediment yield calculation. Sediment transport assessment in headwater areas of catchment in arid region is a major concern for flash flood hazard control in watershed management. Under homogeneous condition of climate geology and land use, the topographic control on erosion and deposition process play a major role in landscape evolution. Erosion and sedimentation phenomena are studied by various researchers, but there is not clearly defined and accepted method to the problem. According to the 1994A B, either our conceptual understanding of the erosion sedimentation problem on the Earth's surface is far from being complete, especially in arid and semi-arid region, or erosion sediment Sedimentation research techniques are still more than art than a science. Sediment yield was studied in the past by two basic type of analysis, namely hydrological and hydraulic approach. Then semi-arid and arid regions are distinctive in terms of erosion and sedimentation yield. Johnson 1982, Hadley 1986, Walling and Webb 1886. The most important agents are as follows: erosion and transport characteristic, basin morphological features, geological layout and soil coverage, vegetation covers factors, land use and management practices. In arid regions, hills are slow primary source of erosion by occasional runoff and flood with channel bank and floodplains as secondary source. The sediment yield phenomenon can be divided into two broad categories as the upland phase and lowland stream. Then, highway safety assessment and recommendation. Road safety assessment RSAS, also referred as road safety audit in safety literature, are a proactive approach to improve road safety. Maintenance based on the present condition must be effected when it's possible to assess residual lives of assets on basis of inspection or test results, and the road area must be observed at least weekly or in wet period more frequently, say daily, in order to visualize defect occurrence leading to minor repairs and improvements to eliminate the cause of defects and to avoid excessive repetition of maintenance effort. In case of unseen and unpredictable repair requirements, urgent maintenance must be undertaken immediately, and it is possible to divert surface water through properly designed canals and earthwork or vegetation plantation, especially plants with deep root possibilities. Then flood hazard reduction. Embankments or stop banks are terminologically referred to as levees. They are designed for restriction of flood water as to well-defined low value and of floodplains. Their construction are simple and mostly constructed from earth fills. Since one of the flood magnitude effect factor is velocity and it's dependent on cross-sectional area, it is possible to enlarge the cross-sectional area to reduce the flood velocity and to spread the water over a large area. For the regulation of floodwaters, temporary impoundment structures such as reservoirs and large dams are constructed. This helps to store water during flooding time and then to release the water to downstream after the flooding at desired location, for instance to groundwater recharge potential areas, in order to reduce the debris flow, mud flow, and possible partial complete landslides. Then points are advised to stick, continuous research, support, information and knowledge collection, assessment and dissemination. The area along the alignment must be mapped from hazard point of view as suggested in this chapter. This report provides the basic information, real-time measurement, guidelines and training principle for public awareness and education, and emergency preparedness. So, thank you guys.